best wishes to all of you. And with you, this is Robenson Jean. I am an electromechanical engineer and also energy engineer. I am involved in the energy sector. I've been working for several years on rural electrification, renewable energy, PV system design, and also in wind energy conversion system. So now in today's class, I'm with you to share some knowledge, or better to make a rise conversation around wind energy, and more precisely about energy generation through wind, including the design and construction of a wind turbine and generator. So let us see what we have today. And the today's class, the reason it is because we can see that nowadays every and every summit they are talking about, in every energy summit they are talking about energy transition, CO2 emissions reduction. They are talking about carbon footprint. They are talking about global warming. And the goal is to reduce the carbon footprint, to reduce the carbon dioxide emissions, and also to increase the renewable energy electricity-based share. So in order to reach such goal, we have to consider the renewable energy integration, such as wind energy, solar energy, geothermal energy, hydroelectric energy. So they are very important, as they are kind of energy that help us to generate electricity or to generate power with a very, very small impact on the environment and also on the society. So that's why this morning we are going to see what is the wind and what is the importance of the wind, and what can we do with wind. What can we extract in the wind? So first of all, it is important to understand what is the wind. So wind, it is the natural motion of the air, and it is like a flow of air that it is moving in a specific direction. And this flow, or this motion of air, is generated by, I can say, directly by the sun, because we have to know that every kind of renewable energy that we are using on the earth, this kind of energy comes from the sun in some way. So in this case, the motion of air is due to the difference of atmospheric pressure. So why do we have a difference in the atmospheric pressure? So this is due to the position of the Earth, the inclined position of the Earth. So when the sun when the sun irradiance arrive on the Earth's surface, so some part of the Earth is heated, and other part is with less temperature. So this creates a difference of pressure. So we have a pressure gradient. So due to the pressure gradient, so there is a movement from the zone of higher pressure to the zone of lower pressure. So this motion of air is wind. And also there are other factors such as the geographical position, or the inequality of the sun irradiation on the Earth's surface, the Coriolis force, and all of these factors contribute to the motion of air. So As we have this motion of air that is raining, so we can take advantage of this motion of air. So let us see. So first of all, there's the temperature and energy balance. So imagine that we do not have a rain on the Earth's surface. What will happen? What will happen? The fact is, one one part of the Earth will be very with a very high temperature, and the other part will be frozen, unfortunately. So the rain help the Earth to maintain an energy balance. So the the airflow is circulating and it is regulating the temperature on the Earth surface. Also, and the same sense, so this help to regulate the climate conditions on the Earth surface or on the different zone. Also, there are other factors for what arena is very important, such as pollination, such as pollination, transportation. Like we do know that in ancient time, people use the arena in order to 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 travel on the sea, and there are other purposes such as mechanical purpose, irrigation, and renewable energy generation. And also, another importance, it is the fact that wind energy is a mature technology. This is mature technology. So let us see some characteristic of wind energy. What happened with wind energy? The main the main importance of wind, it is the fact that we can extract the energy available on the wind. And wind, the energy available is the kinetic energy. As we don't know, if a body is in motion, this body have this body has a kinetic energy, and this kinetic energy is equal to alpha is mass time the square of the velocity. So let us see what happened with wind. Unfortunately, we could extract the energy from the wind, but we have to take into account is a variability. It is variable because every now and then the wind speed is changing. Also, wind is unpredictable. Wind speed is unpredictable. Unpredictable because it is changing, but we do not know what will be the amplitude of a wind velocity in the next second or in the next minute or in the next day. We cannot say that wind speed will be at 10 meters per second in 10 minutes. We cannot say that. So it is unpredictable. So as it is unpredictable, so we cannot make a very good planning when it comes to harvest wind energy. So we are going to see some other characteristic of wind speed, and also we are going to see what we can do in order to mitigate the variability of the wind speed and also the unpredictability of the wind speed. Also, wind has some short and long-term fluctuations. Sometimes we can see some pattern. We can determine some profile on short term and on long term, like seasonal pattern, journal pattern, and year pattern. So there's some information that we can have about the wind. So let us take a look at the wind energy landscape. So what happened? Where is wind energy on the renewable energy mix? So nowadays, like I'm talking about the year of 2023, because for this new year 2024, we do not have yet report. So the report that we have, it is till the first half of 2023. So till the first half of 2023, what happened? We have a record. We have a record for wind and solar. It is the first time that wind and solar together reach around 14% and the electricity share and the world. And it is a record for wind also to reach 8.8% because on the past years the contribution of wind was less than 8%. So it is a record. So the wind electricity base is getting increased even when this contribution is not sufficient because the goal is very high in order to reach the 2050 goals for net zero carbon. So it is the situation of wind energy and that moment. And also, I think it is getting better because there's information from the first half of the past year. So if I think that on January 11th, they will release the full report for the year of 2023. So we will see what happened in the rest of the year. So also wind carries some environmental impacts, unfortunately, and it is related to noise because when someone is living near a wind farm, it is obvious that the noise of the wind turbine or of the blade that are of the blades that are rotating, they will bother you a little, but not too much. But they emit some kind of noise, unfortunately. So it is like an acoustic pollution. Also, there is a visual pollution because when the blades are rotating, so there is the shade the shade of the blades. Sometimes some people report that the shade of the blades are bothering. So it is a kind of visual pollution. And for some reason, and it is why in some places it is difficult, very difficult or impossible to implement wind energy project. And it is why some companies are trying to see which opportunities that we have on the sea. So in order to make another approach like offshore wind power plant. So when I'm when I'm telling offshore wind power plant, it is a wind power plant that is located on the and and the sea area. So other environmental impact, it is biosystem disturbance because it can cause some deviation in the pathway of some species and the migration. So the friends of the animals are always talking about these biosystem disturbance, and also there is some risk to the wildlife safety because sometimes birds are killed, but it is something that is not common, but in some reports, in some articles, they are really reporting some cases and some wind power plant, unfortunately. And the positive environmental impacts, it is the CO2, the carbon dioxide emission reduction. So it is the very best contribution of wind energy system. And nowadays, how is the global trends and wind energy system? So we can see that from 2011 to 2022. So what happened? The addition and the capacity, the addition and installed capacity of wind power plant is getting increasing, even when in 2013 the tendency was uh, was slowed, but it it was getting increased, and then in 2020 it is a boom, even when it is decreasing a little bit in the year of 2022. But the good news it is that in 2023, the result is getting higher, but as we do not have the full report, that was we do not have data for the past year. But if we are considering the first half of the year 2023, we can see that we have a higher value for the generation addition. So in this graph, we are talking about energy. So it is energy addition. So we can see that in the first half of 2023, so more than 100 terawatt hour were added in terms of contribution of wind energy generation. And if we are making an economic approach with which will obviously have a social impact, so we can see that the average price of wind turbines is getting decreasing. So this technology is getting more accessible, is getting more affordable. So obviously the wind electricity share will increase as the technology price is getting slower. So we can see that from 2018 to 2022, so the price of wind turbines is getting unchanged, whereas on in the year 2014, the prices were very high, the price per megawatt. So this is a good news in terms of economic approach. So now let us see the cost of materials. So we can see that the cost of we can see that the technology costs in the key materials prices for wind turbine. So this is the evolution. So from 2017 to 2020 to 2022, or maybe or better to 2021, we can see R is the cost technology trends. So it is getting a little bit higher in terms of percentage. So we can see that we are having a more and more better result to the recent years. So this economic approach helps us to understand that the reason why wind energy generation is getting higher. So this is a global investment in renewable energy. So if we are trying to understand this graph, it is the investment in a billion of US dollars. So look, wind is a little bit behind of solar because the solar investment on the year of 2022 were higher than $300 billion, where wind was around $200 billion. So together, wind and solar is so wind and solar they are having a very high investment. So we can expect a very good result and a very high amount of electricity share based on this kind of technology. So now we have to try to understand how does it work, a wind turbine. So let us considering the wind speed. So if we're talking about wind speed, it is because there is a mass of air in motion. So if it is in motion with the velocity, it contains kinetic energy. So what we can do, we can extract this kinetic energy in order to produce another form of energy. So what we do with wind turbine, it is extracting the kinetic energy contained in the rain and to transform it into mechanical or electrical energy. So how does it work? So let us see the parameters. So the parameters to take into account, it is to take into account the control volume where the wind turbine is located. So the most important factor, it is the cross-sectional area, or better to say, the swept area. So the swept area, it is the area covered by the blades of the wind turbine. Okay, so the power generated or the power available and the rain that is going through this control volume, it is given by 1/2 the density of the air times the cross-sectional area, and also the cubic of the velocity of the wind. So we can see that if the wind speed is higher, so this control volume may contain more power, okay? And if the density of the air is higher, also the value of the power will be higher. And the same way, if we have a small wind turbine, so the power generated will be very small. But if we have a large scale wind turbine, like with a water of more than 50 meter, so this will generate a high amount of power. So this is how we consider the energy contained in the ring. So let us see what happened. So we have to make the difference between the wind turbine and the generator. The wind turbine, it is the machine that we use in order to convert the kinetic energy into mechanical energy. So when the the drag force of the wind pushes the blades of the wind turbine, so this is rotating, and when it's rotating, this rotation is transferred to the shaft of the wind turbine. So this kind of motion available on the shaft of the wind turbine is mechanical energy. And then, in order to take advantage of this mechanical energy, what we use a generator, and this generator can be squirrel cage induction generator, a double fed induction generator, permanent magnet synchronous generator. There is a wide range of generators, but the main purpose of a generator is to transform the mechanical energy at the input into electrical energy at the output. Okay, so inside the generator we have an electromechanical system. So if someone is an electromechanic or electrical engineering, so it is something that we do understand how the mechanical energy is transformed into electrical energy through magnetism and some specific laws related to magnetism in order to generate the electrical energy. So there's two system or there's two subsystem most of the time are mixed together. So when you see a wind turbine, so inside the wind turbine, there is the wind turbine itself and a couplet generator in order to produce directly the electricity from the wind energy. So what happened to the efficiency of a wind turbine? So we have to know that, so this is an example of a generator. This is one of the generator that I use in my laboratory. It is a permanent magnet synchronous generator. So we can see the shaft of the generator. So this is a very small generator. It is a 2 kilowatt generator. So you can see the shaft. So the shaft is here to receive the mechanical energy, and then through this wiring, so these are the permanent magnet that generate a permanent magnetic field, and these are conductors. So we do know that through the Lenz's laws, so if conductors are present in a rotating magnetic field, so this will generate an induced current. So this induced current, it is the current that is generated and the three-phase terminals in order to send the electricity to the conversion system and to use it or to transform it for your personal use. So this is rapidly how it works. But there is a limit. All the energy or all the power available on the ring uh, is not how can I say that the fact is it is not available, but all the available power like kinetic energy is not transformable into electrical energy or mechanical energy. There is a limit, and this limit is known as the Betz limit. So this limit is like that we cannot convert more than 56% of the ring kinetic energy available on the ring into mechanical energy. So due to that, there is a performance coefficient. The performance coefficient, it is the ratio of the willpower produced on the maximum limit, like the the maximum power that we could extract on the ring and the ring speeder with the wind turbine. So this is the formula of the performance coefficient, or sometimes they say power coefficient. So this we will take it into account in the formula of the output power of the wind turbine. So the effective mechanical power generated by the wind turbine is given by the product of the kinetic power with the performance coefficient. So now let us see the real output power, like the electrical power generated. So we have to know that unfortunately it is normal because it is an electromechanical system. If you have an electromechanical system, you will have electrical loss, mechanical loss. So the losses are into these values. So we have losses and the gearbox, if we have gearbox. Unfortunately, in the permanent magnet synchronous generator, we do not have gearbox, but in some other, like in the squirrel cage induction generator, we have gearbox. So in the gearbox, we have losses, mechanical losses, and this is the generator efficiency that take into account mechanical and magnetic losses. And Also, this is the electrical efficiency that take into account the electrical losses. So when the mechanical output power is affected by this efficiency, so we will finally have the output electrical power. And now let us see the design of a wind turbine. So we can identify the wind turbine based on several criteria. Based on the axis, we have the horizontal axis wind turbine. So the blades are rotating around an horizontal axis. So this is this type. Let me make a zoom. Okay. And we have also some this should be VAWT. So in this case, the blades are rotating around a vertical axis wind turbine. So the axis or the shaft of this wind turbine is in a vertical position, and the blades are rotating around. Also, we can identify the wind turbine based on the type of generators that is linked to the wind turbine. So we have some fixed speed wind turbines, and we have variable slip wind turbines. So in this case, what we use a variable resistance and the wiring of the water of the generator in order to have a variable magnetic field. So this will help to make some variation in the velocity of the rotating speed of the shaft of this kind of generator. And this is the doubly felt induction generators. And this is the permanent magnet synchronous generator. It is the same that we have just seen in the earlier picture.
Robenson Jean,
Yes.
there is a question that I think this might be a good time for you to answer. What are the comparative energy unit costs of wind in relation to like hydro, solar, geothermal, atomic, coal, oil? Like where does it rank? Where does wind energy rank as far as cost per energy unit?
Okay. For this question, I will arrive on it a little bit later. The fact is, we have to take into account the size of the application. So on small size, we can see that more often what we do use is a solar system, right? Because solar system is more present, and solar resources also is more present because when the sun shines, it shines for a wide range of spaces, but the rain or the high wind speed is not available everywhere. So for that reason, as high speed is more available on higher altitude and very some specific places, so they are constructing very big wind turbines. So for that reason, the cost of wind energy is higher than solar energy cost. So this is a fact, and we are going to see that when we are going to see when we will see the challenges and those are related to wind energy technology. So a little bit later, we are going to see this. So let us see, and also I have I see they have some other question. Can you rank them in terms of cheapest energy to source most expensive? Yes, okay. We will see that later. Okay. Let's celebrate the power of rain. Okay, there are too many questions. I don't know if I can take the question after in order to keep on advancing so
Yeah, I
you
think
can
that's
see
a good
the
idea.
response. Okay,
Go ahead.
very, very
Every,
good.
everybody save your questions till the end of the presentation. Okay, there we
You
go.
can write down your question on the message and after I will answer. Okay, very good. So now based on the installation places that they are onshore, so when we are on land and they are offshore wind turbine, and also based on the age of the wind turbine. So this is what I was talking about. So let us see what happened. So when the water diameter is less, so we are producing less energy. Okay, but the fact is that on small altitude we do not have a high wind velocity. But when we are getting upper in terms of altitude, so we can have a higher wind speed. So as we can have higher wind speed, so the tallest wind turbine can have a wider swept area, like a larger water diameter. Okay, so you can see that it is expected to have between the recent years, like from 2022 to 2025, some water diameter that reaches 170 meter, and this can generate a nominal power, a rated power, uh, around 5.8 megawatt for only single one wind turbine. So this is very interesting when we compare it to the tallest wind turbine that we had on the year of 2000. So it is very interesting. So this was for onshore wind turbine, but look at the tendencies for offshore wind turbine. So for offshore wind turbine, you can see that the the water diameter can reach wider range. Why? The fact is people don't like to see wind turbine in front of them in some places, in some communities. So the constructor cannot produce very, very, very big or very tall wind turbine. But when we go offshore, when we go on the sea, so where there is no case for noise pollution, visual pollution, so they can go higher and there is less risk, okay? So they can go higher, they can harvest uh, higher wind speed. So that's why you can see that the wind turbine dedicated for offshore application are taller and they have a wider water diameter. So this is a case of Vista wind turbine. Vista is a constructor of wind turbine. So you can see for a 4.2 megawatt wind turbine. So it can manage wind speed from 3 meter per second to 22.5 meter per second. So this is the curtain speed and this is the cutoff speed. So under this wind speed, the wind turbine will not operate. But if we go higher than this wind speed, so the blades of the wind speed will be in the flag position, so the wind speed can flow without turning the blade of the wind turbine. This is for safety. And the water diameter for this specific unit is 150 meter, and the area of the area is 105 meter. So let's see the components of a ring of a of an horizontal axis wind turbine. So the main component of this is the foundation. It is important to have a very good foundation in order to resist with the solicitation. And this is the tower. This is the tower that maintain the height of the wind turbine. And this is the rotor arm. And here we have the blade. This is a three blades wind turbine, and there is an angle of 120 degree between each blade. And this is the nacelle. The nacelle, it is the part that contains the generator linked to the wind turbine. So inside we can see the gearbox at the generator, and this is an anemometer in order to measure the wind speed. So we can be advised when the wind speed is getting very high, in order to activate the brake and to protect the wind turbine. So this is the yaw control for wind orientation. I think in these images it is better. We are getting closer. So the yaw help us to make a kind of control in order to always put the swept area of the wind turbine in front of the headwind, okay, and the main direction of the wind speed. And then we have this brake. This brake is in order to avoid some situations, so like high risk speed, storm, things like that. And this is the gearbox. The gearbox help us to multiply the velocity of the speed, because the direct shaft linked to the rotor of the wind turbine is a low speed shaft. And in order to have a higher efficiency, so it is better to increase the velocity of rotation, so the generator can turn at higher speed in order to manage the frequency, because this is very important to manage the frequency of the generator. And also we have the wind vane. So the wind vane, it is an equipment that helps us to detect the wind direction, so we can adjust the control with the yaw drive in order to always put the wind turbine in front of the headwind. So let us see what is a wind farm. A wind farm is obviously a group of wind turbines that are located in the same location. It may be on the sea or on the land, in order to harvest the wind energy and to generate electricity. Some important parameter for a wind farm. It is the characteristic of the wind turbines, like the rated power, the rated phase voltage, the speed, the frequency, the efficiency, and also some electromechanical components. And also the range of wind that the range of wind speed that the wind turbine can manage. And also, in order to design a wind farm, it is important to determine the demand, because if we do not have demand, it is not interesting to invest in something. So we have to localize the demand take into account the size of the demand and the distance of the demand. And also the location of the site. This is a very important in order to make the wind energy assessment. This is very important. Also, we have the wind speed present in this region. The surface rawness, because the surface rawness does influence the wind speed. For instance, if the lane is a lane of grass, the wind speed will be different if it is a lane of stones. For instance, if there are a lot of amount of trees, the wind speed in this region will be different if it is a desert place. So these are information that we have to take into account, and also we have to take into account the available technology, because we can have a very high wind speed profile in a region, but if we do not select the correct technology, so our system will not be and with the higher efficiency that it could. Now we have the capacity factor. So the capacity factor, it is when we take into account the annual energy produced in comparison with the energy that the wind farm could produce. So this ratio gives us the capacity factor of the power plant. So we can select a period, and generally the selected period is a year. So this is the amount of hour in a year. This is the rated power of the generator, and this is the annual energy production. But someone can say that obviously the annual energy produced will always be the value and the denominator. But no, the reason it is because a wind turbine is not constantly generated at rated power. Sometimes when wind speed is slower, we are not generating at rated power. We are generating less than rated power. So for that reason, the annual energy produced is always less than the available of the amount of power that we could produce if the wind turbine was operated constantly through the year at rated power. Okay, and the range for capacity factor is around 40%, like 0.4. 0.4, 0.3. If you have a wind farm with a capacity factor of 30%, it is a very good result. But once the electricity is produced, what happens? We have to implement an energy conversion system in order to harvest the energy. So the energy produced on the wind turbine can be available to the grid or at your house, because even when the wind turbine is producing an alternating current, you cannot directly use this kind of energy due to some parasite, some harmonic current. So we have to clean in some way. We have to clean this kind of energy. So what happened? We have the wind turbine. Here we have mechanical power. We transform it with the generator into electrical energy. So once we transform it, we have alternating current. So we have to transform it into DC. Once we transform it into DC, so in the DC zone, we will use this link as an energy buffer in order to protect both sides, the machine side and the grid side. So if we have some dynamic issues on the side, this will not go in this part. And also, when wind speed is fluctuating, the dynamic issues are related to to wind speed will not be transferred to the side of the grid. So this is like an energy buffer, and it has coupling rules. And after this, we have the inverter that transform from DC to AC, and then at the output of the inverter, we have a filter in order to reduce the harmonics, okay? In order to reduce the harmonic distortion and then inject into the grid. But in blue, we have the control system. We have plain some references like the grid voltage, the DC link voltage, and also control the inverter in such way that we can respect the frequency of the grid, the voltage of the grid, and also to manage reactive power. And now, in order to in order to manage a such system, we have to make a data analysis. We have to make a data assessment for the wind. So we have to have a wind speed data for the places, and then we'll make some treatment and analysis of the measured data. We will set some time series data set, and through this time series data set, we will try to see the tendencies of the wind speed through days, months, year, in order to make some forecast. It is not predictable, but we can go a little bit closer in order to make a better planification for energy production. And also we can make statistical approaches, and we can also make a wind speed extrapolation, because sometimes you will have the wind speed on a position, but in another position, no. But what happened, once you have the wind speed in 3 point, you can interpolate the wind speed for other location. And also you can do it vertically. If you have the wind speed at an altitude, and you have the rawness of the surface, so you can also extrapolate in order to have the wind speed at higher level. And all of these are for forecast techniques in order to make a planification and make an annual energy output determination, and then make an evaluation of the cost of energy, because this is an important factor in in energy production, because this is the factor that we can compare to other kind of energy, like with solar, with geothermal energy, or with fossil fuel based energy. So let us see. So in order to make all of those things, we have to count on measurement station. So this is how us we see the world. It is like a global grid. So in each point, if you have the wind speed, so in the point between the mesh, so you can interpolate in order to have wind speed from unknown places, or wind speed at a higher level. So this is in order to determine some density probability function in order to make a statistical approach. This is the variable distribution function that we can use when we have a time series of data set, so we can transform it into a density probability function in order to have how often I can have a high wind speed. And this is often coupled with this kind of graph, where we can see so in which range of wind speed will stay. So this is wind speed, this is power, this is for a given wind turbine. So you can see at the before the cut-in speed, we are not generating power. And inside this region, the power is getting increased. But after this this V rated, like the rated wind speed, we are under rated region power. So in this region, even when wind speed is increasing, the wind turbine will always generate the rated power. But after this region, like after the cutoff speed, the wind turbine will be in a flag position in order to stop generating for security purpose. And this is a formula for vertical extrapolation. Like as I told you before, if you have this should be VZ1. So if I have the velocity at the Z1 level and I need the velocity of wind at Z2 level, so I can use this formula in order to have the velocity at higher level and see if I cannot harvest the wind speed at a higher level. And the instrumentation used for measurement are anemometer. We have a cup anemometer that we use to measure at 10 meter at 10 meter of the sea level. And there is a sonic anemometer when we are on the mountain, and there are pocket anemometer that we can use in every situation. It is like a portable anemometer. And the wind vane, it is to detect the wind direction in order to always put the wind turbine, the surf area of the wind turbine in front of the headwind. And all of those, it is in order to mitigate the variability effect present on the wind, and the unpredictability is the unpredictable characteristic of wind. So this is an example of anemometer with a wind vane. So this is the cup anemometer that is often used to measure wind speed at 10 meters above sea level. But what happens if you do not have a measurement station and you want to make wind energy assessment? So there is available wind database. They are very free. Once you have your location, your places, your site, so you can go on the database in order to have some data set, and the data set can be available in CSV and Excel data sheet. There are RASPA, ERA5, MERA2, Global Wind Atlas, Power Data Access Viewer. This is NASA features. And here, for instance, we have the interface of Data Access Viewer. So you can see that I'm here in Mexico. I can select the place or a range. So here you can see that you can give the upper limit, the bottom limit, and then for the selected area, you will have the wind speed at several range, the range that you want. If you want it at 10 meter above sea level, okay. At 50 meter, it is okay. At 100 meter, okay. So this you can use it also for solar energy assessment. So this is a very powerful software. And this is the interface of Global Wind Atlas. And through this, for instance, you can see that at 10 meters above sea level, there are some places in the Caribbean region that has some interesting potential for wind. Like, for instance, the west coast of America, And here, the isthmus of Tehuantepec in the south of Mexico and the Oaxaca state, and the south of the Haiti Islands, the north of South America, the north of Colombia. They are very high potential. So this is something that you can use in order to assess the wind energy. For instance, if you plan to implement a wind power plant, so obviously this part of Mexico, it is not a good place. It is not a good place because you can see that at 10 meter above the level of the sea. So it's no, but this is at 10 meter above the level of the sea, but at 50 meter, the result can be very different. At 100 meter, the result can be very different. Okay. And also this help you to select the technology, like the rated power for the corresponding wind turbine, the height of the wind turbine, and the range of wind speed, and the power curve of the selected wind turbine. So this is a very, very powerful software in order to make a wind energy assessment. And also, you can use the data from the wind database, like from ERA 5, from NERA 2, from RAPS, in order to make reanalysis, in order to increase the spatial or the temporal resolution of the data set. So you can mix the data set from the online wind database with measured data in order to improve the resolution of your own data set. So you can use a programming language such as Python, C, Java, C Sharp, or C++, and you can use mathematical tools like interpolation, extrapolation. We have just seen the formula for vertical extrapolation with Weibull. You can use the probability statistic tools in order to improve your data set, and also the data analysis tools such as Power BI, Python, Excel, ArcGIS, OMEPro, Samuel. So they are available tools. Some of them are not free, but some of them are very free. You can use them and take some capacitation in order to 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 master them. And for metric and financial point of view, you can use OMEPro, because OMEPro can help you to compare the energy cost for several scenarios, like the leveling cost of energy, the LCO. So you can use OMEPro, Samuel, and there are others that are not free and that I do not mention. For instance, this is this is an analysis that I was doing. This data or data from the state of Tamaulipas, of the northeast of Mexico. So this is the data measured in the January 1st of the year of 2019. And this is the day of January 1st of 2019. And you can see that the blue line, it is wind speed at 80 meter. It is the altitude. And this is wind speed at 60 meter. The gray, wind speed at 40 meter. The yellow one, wind speed at 20 meter. So look what happened. Oh, I think it is the it is the it is the reverse. It is the reverse that I take. So let's consider that this is at 20 meter, 40 meter, 60 meter. and 80 meters. So what happened here, we can see when we are closer to the ground level, the wind speed is lower. But when we are getting higher, the wind speed is getting higher. So this is what we can see from this kind of analysis. And now we do have some challenges and issues that is related to wind energy. We have a technical constraint. The technical constraint is when it comes to assess the balance of the energy, like the balance between the demand and the offer. Sometimes you can have a possibility to implement a wind farm, but the demand that is close to this side is not high. So in such cases, what you can do, it is try to inject on the main grid. You are not producing for a specific community, but you're producing in order to increase the electricity share into the main grid and to increase the renewable energy electricity share. This is the most important. So the impact of this will be a reduction at the other side of the fossil fuel energy utilization. And also we have environmental impact assessment that is important when it comes to implement a wind speed or wind energy project. So it is important to see the emissions reduction, how this project will impact the wildlife, the noise, how to manage it. And also, sometimes we have to deal with some land conflicts. And also, we have to assess the lifetime of the project. So we are not going to make years of discussion in order to implement a system that will last only 5 years. So obviously, it is important to assess a long lifetime for the project that we are implementing. Also, there's the social impact assessment that is very important. Sometimes it is very important to integrate the nearby communities into the project. And also, we have to assess the services that will provide and the nearby communities. And it is very important to think into account health and safety, job creations. So these are things that are very important for social impact assessment. And for the cost determination, there is a triple. We have the installation cost, the operation and maintenance cost, and also there's the replacement cost, because sometimes after 5 years or after 10 years, there are some parts of the system that we will have to replace in order to ensure a very good lifetime for the system. And there is the site assessment and the point of view of and a technical point of view, environmental, social, political point of view. For instance, a site can be a very good place for a wind power plant, but if it is a protected area, we cannot go through. So these are things that we have to take into account. And the land acquisition also is a very important part. We have to set the policies before, try to have a very good agreement with all the stakeholders. And sometimes a common mistake is to not include the local communities into the discussion. So this is a common mistake, but we have to be aware in order to include them and to take their words into consideration, and so everyone could be happy at the end of the day. So in order to conclude, we have some report that we can check And in this report, we'll have the response for a lot of questions, such as the response, the answers related to cost of energy. So there is the arena, the IEA, the Ember reports. All of these are instances that release an annual report, and we have the Global Wind Energy Council. We have Bloomberg Global Wind Atlas. So they have a very interesting yearly report, and sometimes it is a report on half year, the first half, the second half. So they are very interesting. In the arena report, you can see that a lot of information related to the cost of energy. So we can compare the cost of energy and also the the contribution, like the electricity share, and how they contribute to reduce the carbon emission, each one. Because sometimes it is not only the cost, but the contribution into the reduction of uh, greenhouse gases emission. And the tendencies it is to follow the kind of energy, the type of energy that help us to reach the sustainable development goal and to reach the net zero carbon emission in the horizon of 2050. So I encourage all of you to go through research area that are related to renewable energy in order to increase the renewable electricity share and to reduce the CO2 emission, greenhouse gases emission, and areas are data sciences, aerodynamics, mechanics, electromechanics, automatics, power electronics, power systems, electrical engineering. So I encourage you to go in this direction as you're here. So thank you so much, and ready for the question. So let's go.
Actually, we have run out of time. We don't have any more time for questions because we have to move on to other meetings. So
Okay.
I suggest you put your email into chat and have the students send you the questions by email, because
Okay,
there's a
very good.
lot of questions. And as they write their assignments, I really want all of the students to have an opportunity to ask you their questions.
Let me put put
And
it to
make sure you put
everyone.
the to everyone, yes.
Everyone.
There. That's mmusi dot oratile or tile at gmail.com. No, wait, that's somebody else. No, wait. The
Oh, this is
presenter is going
mine.
to put his email in chat, and so that everybody can actually write to him. There it is. Robenson Jean .1 at gmail.com.
Yeah,
There it is.
this is it.
So as you write your assignments and you think of questions, write to Robenson Jean, and that will help you develop your ideas for your assignments. Because really, there are a lot of great questions in chat, and there's just too many for us to go through right now.
Okay. So thank you so much, everyone. And I'm very sorry because I see that there are live classes every day, Monday.